temporarily store and take space and devise intelligence tests for chimps. One test is for what's called working memory, the brain's ability to temporarily store and use information. The numbers 1 to 9 are randomly scattered across a touch screen. The chimp looks at them for as long as it needs.
Try to do this on your own. See how difficult it is.
As soon as one is touched, the other numbers are hidden and must now be remembered. We volunteered Chris, the director of this program, to demonstrate this technique. He's a college graduate and a crossword addict, but how good is his working memory? When Chris reckons he has memorized the layout, he touches 1. When the others are hidden, he must try to recall 2 to 9 in ascending order.
It takes me ages to remember where they're all placed. And then I think I've got it. It's really very, very difficult.
In 30 attempts, Chris only once reached 9 without making a mistake.
Do you think that's hard?
Yeah. It's blank over. My mind's been blank over as well.
Whenever you move at the same pace, he correctly remembers the numbers almost 90% of the time.
All right, so that's pretty impressive, right? Okay. So what am I trying to show you here? What I'm trying to explain to you? Working memory. Okay. Obviously, that chimp has been trained that he's going to get a treat for getting those done, right? Okay. So that's his kind of motivator. Okay. But that chimp has much better working memory than what we have. Okay. And every day there are things that you guys experience and deal with that are minimizing your working memory. Okay. And what do I mean by working memory? What are they talking about this? Your memory is like a file cabinet. Okay. If I were to open the drawers in that filing cabinet over there, I have like one file, a bunch of other garbage in there, but it's really easy to find that one file and then to access the information that's in that file, right? Okay. If that filing cabinet was the filing cabinet that I took over when I first got a job here, that thing weighed like 800 pounds because of all the papers that were in it. All that stuff was there. Everything I needed was there, but it took hours to find the thing that I was looking for. Does that make sense? Your brains are that way. Everything's there. Okay? When we learn something, we learn it, and it's there. But how we file it away and how we then access it and use it, it's different for every person. But for some people, it's really easy. Some people, it's really hard to access it and reuse it and apply it. Okay? So what I want you guys to understand is that your working memory is short-term and temporary. That's what they talk about, right? Now, that's a relative word. Temporary might mean the next 5 minutes. It might mean the next 5 days. It might mean the next 5 years. It's temporary, okay? But it will fail you at some point. And if we know that our memory is going to fail us at some point, then maybe we can start to develop procedures that try to counteract that or that are going to attack that failure. Does that make sense? Okay? Think about this. Think about your phone numbers. I was trying to get kind of towards this a little bit ago. Does anybody know, like their mom, if I were to ask what's your mom's phone number, your cell phone number, can you tell me that? Okay, you probably use your mom's cell phone number, right? Okay. If you're friends with, think about your best friend. Do you know their cell phone number?
Yes.
Okay, some of you say yes, some of you say no, okay? If you don't, think about this. When I look at my cell phone and I want to call somebody, I just got to call their name, right? Okay, I don't have to remember the 10 digits that go with that name. When I was younger, we had phones on the wall, okay? And you had to be attached to the wall. So there's no going to my bedroom and talk to my friends or whatever. I stayed at the kitchen table, okay? And I had to either dial with a rotary, okay? You guys seen those before, those old phones, okay? Or I had touchpad or whatever. Mom and Dad got more advanced than touchpad. If I had to call my best friend, I had to remember the number 641-2501, okay? And I had maybe, this might be hard to believe, but I had a couple more friends than that. I had to remember more phone numbers. You guys don't have to do that, right? If I asked you to write down your top 8 friends and write down their phone numbers, you probably can't do it because technology is inhibiting our working memory. When I had to use that, right? Okay, I couldn't call my friends if I didn't know the phone number. Okay, and I had to store that in my head. Now, if we understand the idea that there are things in our lives that are forcing us to just kind of be mindless, right? Our technology, our cell phones, they do a lot of stuff for us. Okay, so we're not practicing this working memory. Okay, that chimp is going to be a lot better at that the more he does that, right? That man, first time, say he got one out of 30 times. If he does that 2,000 times and does it for 30 days in a row, he's going to get better, right? But we're not getting better at a lot of things because we're not letting our working memory develop. We're not filing things the way we should in our filing cabinets or in our minds, okay? So I want you to kind of understand that as we start learning more and more theorems throughout today and throughout the rest of the course.
Not only has the guy barely done that compared to the amount of time done it, but he's not getting a treat.
Well, I mean, so here's the thing. He's not getting a treat that he eats, but he's getting the intrinsic satisfaction of completing that task. Does that make sense? And that's something also we got to think about as students, okay? Huh? What did I say? Satisfaction. That's the word. All right, so satisfaction. When I'm doing a math problem, I'm not getting a treat. I'm not getting a Dairy Queen Blizzard after every time I complete a problem, right? But I'm getting the satisfaction that I've addressed something that I've been taught and I'm able to reuse that, and there's satisfaction there, okay? There should be. If there's not, then you probably need to leave the classroom, okay? Because we're trying to develop ourselves into learners, okay? And there's satisfaction in completing something, okay? Now, that being said, I want to get into today's stuff and using that idea of how we store things, how we schematically structure our memory can help us with all these theorems. You're going to see throughout this course, guys, there's hundreds of theorems. Throughout mathematics, there's thousands of theorems. Okay? We want to structure them so we don't have to remember 1,000 statements. Okay? And that's kind of what the initial purpose of Chapter 2 was, is so that we can develop relationships that allow us to kind of cut our amount of theorems in half that we have to remember. Okay, the more we have to remember, the more likely we're going to forget things. Okay, I can maybe remember 4 friends' phone numbers, 5 friends' phone numbers. If you give me 20, I'm not going to remember all 20. Okay, but things that I use, things that I work with all the time, okay, the better I kind of structure that in my mind, the more likely I'm going to remember them for the long term. Okay. So proving lines, parallels, today's stuff. What I want you to understand is today, we're going to start off not knowing anything about the lines. We do not know whether the lines are parallel or not. We're then going to see a relationship about the angles, and the angles then lead me to my conclusion about my lines. So when we look at this, I'll just do one of these with, something like this. Okay? Look at those 2 lines. Look at the purple line and the blue line. Okay? Would you guys agree that those are not parallel? Okay? Now look at the green angles. What kind of angles are those? Name them based on their location. Alternate exterior. Okay? What do you know about the comparison of those alternate exterior angles? Those alternate exterior angles. What's the relationship between their values? They're different, right? They're incongruent. Okay, those are the relationships we have, right? Congruency or incongruency. Okay? Here they're incongruent. Okay, they're not the same. So if the angles are not the same, what's that tell me about those 2 lines? They're not parallel. And look at the algebra up in the left-hand corner. Okay, that bottom one is the blue one. So 0.2 is that blue one, and negative 0.11 is the purple one. Haven't we talked about in algebra how these numbers here, whoa, that number there and that number there have to be what to one another in order for the lines to be parallel? They have to be equal. They have to be the same. Okay, so let's see if we can force those angles to be congruent. Okay, so let me just move this one up here. If I move that one, you see what's happening to that angle? It's doing what? Getting smaller and smaller, right? And when I force it to be 131.84, like the other one, I force congruency on the angles. What's that do to my line? Makes them parallel. Huh? Just let them be what they want to be? Yeah. Okay. Okay. So here we go. We force a condition on angles, and then that produces a relationship about the line. Okay? Every theorem we talked about today is the converse of a theorem we talked about last week. Okay? So last week we said if lines are parallel, then corresponding angles are congruent, right? I'm going to reverse that. I'm going to say today, if corresponding angles are congruent, which is what this theorem down here at the bottom is saying, if corresponding angles are congruent, then the lines are parallel. Okay? So there in red, it tells you what last week's theorem was. And then in the box on the bottom, it tells us today's theorem. And those two things are converses of one another, right? Okay? We talked about in mathematics, provided an if-then statement, we do not reverse it until told later that you are able to reverse it. So given that red statement last week, during last week's analysis of this information, we were not able to reverse it. Today, we see the converse is true. Today, we're allowed to reverse it. Okay? Every statement throughout the course you do not reverse until they tell you you can. And here they're telling us that we can. Does that make sense? Okay? If you remember, when we have two if-then statements that are true, and they're converses of one another, we can condense that information into a what? What do I call that purple statement up there, that blue statement, whatever color that is? That's a biconditional statement. Okay? Two lines are parallel if and only if corresponding angles are congruent. I don't want to say this class isn't like an honors geometry, but an honors geometry, I think we would focus more on a lot less algebra, okay, more of the thought and logic of this course, okay? But if this was a kind of a higher tiered geometry course, okay, that's the way that these two statements would be presented to you in an honors geometry textbook. Okay, they would write it this way. And every other theorem that can be written as a grouping of theorems that are converse to one another, both true, would be written as biconditional. Your textbook takes the approach that says, we're not going to write too many biconditionals at the beginning of the year because we feel that the student is not comfortable yet understanding that when they see the words if and only if, there's two statements that come from that. Okay? There's two pieces of logic that come from that. That is one way to file things away in our memory. Okay? That stores two statements instead of one. Does that make sense? Okay? Or inside one statement, it stores two ideas. Okay? Instead of having two separate statements for it. Everybody kind of on the same page there? So that's one of the purposes of if and only if statements are biconditional. It condenses our ideas into one statement, and it's easier to store, and it's easier to recall and use and apply. Okay? So, how can we then maybe make a link between that and everything else that we learned last week? Okay? So last week, actually let me just put a new slide in here. You guys don't think satisfaction is a word? You're not living. All right. if two lines are parallel, okay, let's write it this way. If two parallel lines are cut by a transversal, then all right, so last week we learned 4 theorems, right? Those 4 theorems, 3 of them said if two parallel lines are cut by a transversal, then this type of angle is congruent. Those types of angles were corresponding. We could have had alternate interior, and we could have had alternate exterior in those spots, right? Does that kind of make sense? Okay. So that statement right there collectively store 3 theorems as one statement because of the relationship of how those theorems were all kind of written compared to one another. They're very similar in structure. Okay. Now, there was a 4th one, as a postulate, but it basically said same side interior angles are what? Supplementary, right? So I don't want to learn 4 separate theorems and learn them if two parallel lines are cut by transversal, then corresponding angles are congruent. If two parallel lines cut by transversal, alternate interior angles are congruent. I want to learn that, hey, they're structured the same way. Let's replace some of the words, some of the verbiage that we're using in the structure so we can encapsulate those 4 ideas at once. Okay? So now I've effectively remembered or filed away 4 ideas with one statement. Does that make sense? Okay? Now what's the benefit of converses? If I know what a converse is, I'm now going to add this idea. So that relationship, okay, so that statement up there, that first statement, encapsulates 4 ideas. Add to it the phrase that converses are true, and that statement now encapsulates 8 total theorems. And now I've stored those in my memory a little bit better than 8 separate individual statements. Does that make sense to everybody? Okay. Is that like your cell phone where instead of storing 10 numbers for Lex, I store his name? Instead of storing 10 numbers for Canyon, I store his name. Instead of 10 numbers for Ty, I store his name. Does that make sense? Okay. And then when I want to do a group chat, maybe I got those three people in the same group text or whatever. Okay. And I can create that as its own group. Okay. So when we are dealing with things in this class, guys, and across all of your learning, structuring the way you remember something is going to allow you to access it easier, quicker, and it's going to allow you to apply it more efficiently. Okay? What happens in this, I'm not going to let you write these down. I'm not going to give you time to write these down. If you want to, by all means, go back to this PowerPoint and write all those theorems down. Okay? But if we know, and my thought is, my hope is that we know the theorems from last week. Okay? We know what converses are, flipping this and this. So that means you can write these off your memory of what you already know. Okay? And these are going to be true. When we get to homework questions in this course, or this section, they're not very difficult. You're going to find out that they're very similar to what we've already done. If I look at this, the question is going to say, solve for x that is going to make A parallel to B. Okay, you can't see, I've zoomed in and cut off the directions, but it says, find the x value for which A is parallel to B. Okay? So I don't know that A is parallel to B, but I'm going to try to force them to be parallel. And one of the relationships, the only relationship that can exist between those 2 angles, if A is going to be parallel to B, is that those 2 angles have to be what to one another? Supplementary. So if I force the supplementary relationship, it is okay with angles. If we're going to force that, we can now solve for the x value that makes those 2 angles supplementary. And we can do that algebra, right? then it gives you x to be 30. Okay? If x is 30, that's the only number that we can use for x that's going to make those lines A and B parallel. Any other number, 30.1, is going to make those non-parallel. Is that right? Is that the same thing, the same exact equation, if I would have started you off with A is parallel to B and asked you to find x? Same thing, isn't it?
Wouldn't it be possible, like if the lines were to, that the lines could be tilted and the same side interior angles still be supplementary? Like the rest of them wouldn't be able to relate to one another, so you probably technically
See. So you're saying, can I ever take there we go. So you're saying, can I ever take those two, and even though these lines are not parallel, that those two be supplementary?
Yeah.
Okay? It won't work. Because here's the thing, if those are going to be supplementary, and it's the idea of that being supplementary to these two being a linear pair, and these two being a linear pair, if these lines are going to be parallel, then these two angles here would have to be congruent, right? And the only way that those two are going to be congruent is when that line and that line are parallel. So it's a relationship between the linear pairs and the alternate interior angles there that kind of contradict the idea that those could be at some point supplementary. Maybe we'll go through that proof at some point.
Can I like call it something else that's call it like forcing them? Makes you feel uncomfortable.
encouraging.
Yeah, we'll encourage them. So we get to this. Okay, what does the relationship have to be here for A to be parallel to B? Jimmy? Yeah, so those two angles, in order for A to be parallel to B, those two angles have to be supplementary. Okay? In your homework, you're going to see questions like this. Okay? They're going to tell you, and that's what's kind of different about this section, is that they're going to tell you which lines you have to look at. We want L to be parallel to M. So if I call this T, am I going to use that line T if I'm trying to force L and M to be parallel? Do I care about T if I'm going to try to show L and M parallel? No, T is not going to be any use to us here. So it's just adding kind of that visual clutter. If we get rid of that, it's just that traditional set of lines being cut by a transversal. Now, is there a relationship between an alternate I don't want to say it that way, an exterior angle and an interior angle that are on alternate sides? There's no link there, right? Okay. This is 105. What's this angle here?
105.
105. And now what's the relationship between those if L and M are going to be parallel? Supplementary. Okay. So I'm going to let you guys, you see a lot of supplementary in this case, in the questions that I have up here. Let's see if this one's any different. I'll let you guys do the algebra. I don't think it's anything that's extremely difficult right now with these examples. Again, we're trying to force L and M to be parallel. Okay? What values of X are going to do that? You have to pay attention to the transversals that are useful to you. If I look at L and M, those are the two lines that we want. Okay? If I look at this 5X or the 2X and the 5X plus 40, a lot of those, the 2X and the 5X plus 40, what transversal, X or T, is helping make the 2X and the 5X plus 40? T. Okay? So X predominantly is not a very useful transversal. It's not even providing me anything down here. So it might even make sense to even have that stuff down there maybe. Okay? Now this 5x, is that even an angle created with the parallel lines? Or the lines that we want to be parallel? This 5x is made by the transversals, isn't it? So in retrospect, the 5x really isn't useful. Can we break this thing down, even though it was cluttered at the beginning, can we break it down to that picture? And again, maybe I transfer the 2x to here. What do you know about that 2x? And maybe that angle right there, if the lines are going to be parallel. They have to be supplementary. Or maybe you move the 5x plus 40 to right there, and it has to be a same side interior there, right? Okay. Now, all the examples we saw here, by no reason of mine, showed that you're trying to use that supplementary idea, but it can be corresponding angles can be congruent, alternate exterior angles, and alternate interior angles can be congruent. And that could be the relationship that's going to make your angles, make your lines parallel. There's assignment 3.3 online due tomorrow.